Hello everyone. Today I and my team is going to introduce you to some simple concepts of data science used in the classification problem, which was our project. Our problem statement is we want to classify the quality of red wine as good or bad, and we have taken 0 for bad and 1 for good. Wine quality prediction, introduction to data science project, and we have part C, machine learning, that is a classification problem. Our members are Asta Agarwal, Amisha Gupta, Divya Vaid, and Komal Kungwani. As you know, wine tasting and quality testing is a popular activity done all around the world. So let's talk something about our data set. We have taken data set from the Kaggle website, as you can see from here. Attributes in this data set are fixed acidity, volatile acidity, citric acid, residual sugar, chlorides, free sulfur dioxide, total sulfur dioxide, density, pH, sulfates, quality, and alcohol. We have imported some Python modules, namely NumPy, which is used for manipulation of arithmetic data, pandas for data handling, Seaborn and Metaplot library for plotting graphs in an interactive fashion, and lastly warnings, because there are some depreciated feature warnings and data type conversion warnings. So in this we are reading the wine CSV file, and data.head is giving you the first 5 rows of the data set. Since every data set contains null values, outliers, zero values, and this may affect the accuracy, so data cleaning is required in our data set as well. So we are going to check if there is any thing which we need to clean in our data. So this is printing all the columns, all the attributes of the data set, and this data.info is telling us that we have total of 1599 rows, and all the attributes have non-null values, and these attributes are float 64, and this quality attribute is integer attribute. We can also see that the attributes are all numerical, and here we have taken quality attribute as our class attribute. So this will be our output variable, which will be predicted by classification algorithm we are going to use. Our data contains all non-null values, so we don't need to have cleaning for that. Here we have plotted the bar graph for to see the quality distribution of our data set. We can see that our quality lies between 3 to 8, and most of the quality lies between 5 to 6. Now here we have box plots to study individual attribute relationship with quality. So you can see here, these are all the box plots. In the box plot for chlorides, you can see that there are so many outliers for chlorides, and the chloride ranges from 0.08 to 0.2, which is very less range. In residual sugar also the range is less, and there are so many outliers. The same is inferred in sulfates as well. Other box plots are fine. Here we have described the data. This is another statistical method to analyze the data. We can see that mean of the some attributes vary largely. You can see that mean for fixed acidity is 8.3, mean for residual sugar is 2.5, while that for volatile acidity is 0.52, and that for citric acid is 0.27, and here comes total sulfur dioxide, which has mean 46.466. So it varies greatly. This indicates that we need normalization for these attributes before classification. From the box plots and count plots, it seems feasible to divide the attribute quality as 0 for quality greater than 5.5, because count is more below the value of 5.5 in the sample data set. So by this we have divided the quality into two parts, 0 and 1. 1 if the quality is greater than 5.5, 0 if it is less than 5.5. And we are checking the counts of both the quality. So quality 1 count is 855 while 0 is 744. Now we are going to do some principal component analysis, and this is to observe the variance explained by each of the components and the associated weights assigned to each attribute. Now the result will help us in deciding that which attributes are unnecessary and which should be discarded from the dataset. We have taken 4 dimensions for it, and this is the result we obtained after principal component analysis. From this, we can observe that 94.88% of the variance is explained in dimension 1. Okay, and rest 3 dimensions contribute to very little variance. In dimension 1, most of the feature weight is associated with the total sulfur dioxide and free sulfur dioxide. See, total sulfur dioxide is here, which is 0.9757, and free sulfur dioxide, which is 0.21. Others, you can see it is very less. We can infer that total sulfur dioxide and free sulfur dioxide are very important for our prediction of wine quality. You can also see that weights associated with density and chlorides are almost 0. So these can be neglected from our data set for further analysis. Here we are calculating the correlation matrix for further analysis, and you can see that this is the plot for it. From this we can see that fixed acidity, citric acid, sulfates and alcohol are positively related to quality, while free sulfur dioxide, chlorides, density, total sulfur dioxide, volatile acidity are negatively correlated with quality, while residual sugar has 0 correlation with the quality. Now here we have plotted these scatter plots. From this scatter plot, we can see that none of the attributes is showing any linear correlation. Quality of wine lies majorly of a small range of chlorides, as vertical lines can be seen for chlorides. Density and volatile acidity show rough and distributed correlation. Our principal component analysis also showed that these attributes have almost no weight in the contribution. Hence, these attributes can be dropped. And also, good and bad class attribute is roughly correlated here. So, application of support vector machines is not feasible in this dataset. On the basis of above discussion, we have concluded that attributes chlorides, density, volatile acidity can be dropped, and since there are not so many attributes, we are only dropping these 3 attributes. Now let's recall something about k nearest neighbor algorithm. It is based on feature similarity. It is one of the simplest supervised machine learning algorithm, and it is best suited for small amount of data. And since our data set is small and fully numerical, KNNs would be feasible and make a good choice as a classification model. Also, from principal component analysis, we saw that the attributes are not at all correlated. Hence, decision trees would also make a good classification model. So first we are splitting the data into training test and the test set. Scaling is needed here because attribute values ranges varied widely. Hence, we are using standard scalar to transform the data, and here we have used standard scalar. To apply KNN classifier, we use sklearn library. Here we have plotted a graph, precision value versus k, and for that we can see here that precision is coming maximum for value of 2. For k value equals 2, it's coming maximum. So we can take k equals 2 because this is giving maximum precision. Now we are taking the Euclidean distance for k nearest neighbors. From this we have calculated the confusion matrix, and you can see this is the confusion matrix and this is the confusion matrix plot. And we have calculated precision, recall, F1 score. So precision is coming out to be 0.99, recall also F1 score 0.99 and 0.99, and accuracy is coming out to be 0.99. So we can see that using KN algorithm we are getting accuracy of 99%, which is highly appreciated. Now here we are using decision trees. So we have a classifier, that is decision tree classifier, and again the training set of X and the Y, we are putting it as arguments, and from this we are predicting the test data. And now we have to calculate the confusion matrix, and from this we have calculated the confusion matrix, and this is the confusion matrix plot again. And here we can see that precision is coming out to be 1, recall 1, F1 measure is also 1, and you can see that accuracy is 1.0 and gives 100% accurate result from decision trees. So what we concluded from all this project is that both the algorithms are predicting high accuracy levels. One is giving 99% and the other one is giving 100% result. And this shows that an analogy is true and both of them can be used for classification of this data set. Decision trees is giving a better results with accuracy 1, whereas the accuracy shown by KNN is 0.99. After all this analysis that included data pre-processing, visualization and feature selection, we observed that not all features were necessary or contributing in predicting the quality time. Also, no attributes showed positive linear correlation with quality. From scatter matrix we showed that scatter matrix during component analysis led us to drop chlorides, density and volatile acidity, and we haven't considered it in our selection. And this all sums our data science project, and this project is made by Astha Agrawal, Komal Kugwani, Amisha Gupta and Divya Bhatt. Thanks. I hope you liked this project.